Okay, so yesterday we went through the reading about superposition, and we learned some key vocab words from the reading. And we put on page 15, we already went through and did these definitions. If you don't already have all 5 of them filled in, why does that do that? If you don't have all 5 of them already filled in, then you need to fill them in now. So I think this class has them. Maybe some of kids from other classes might not have them all in yet, because we did run out of time. Do you guys all have them filled in? Okay. What we're going to do is I'm going to have you group up, groups of 2 or 3. And we're gonna play with some Play-Doh. But here's the thing, while you're playing with Play-Doh, we're not just doing a free-for-all. We are going to go through each one of these. For example, we're gonna start with principle of original. In fact, how about we'll do it this way. Pair up groups of 3 or 2 or 3 and come grab some Play-Doh. Or we can do like 2 groups of 2 next to another 2 group of 2. 1 Play-Doh per group. 1 Play-Doh per group.
What is this?
Hang on, but once you get it.
Who's there? This one here.
Ryder, why don't you join that group over there? Yep. And yeah, sure, that works. Do you guys want to partner up, or do you want to go just join another group? I don't mind either way. Do you want to work together, or do you want to go join another group? Just work together, that works great. Okay, perfect. Do you just want to squish the tables together or go back to the table? That's up to you. Table might be more comfortable. That's up to you though. All right, so all my groups have 1 thing of Play-Doh, correct?
Yeah.
What I need you to do is take out the entire hunk of Play-Doh.
Get out.
And try to mix your, or try to cut your Play-Doh in about 2 even pieces. Even-ish pieces. They don't have to be perfect.
Oh, yeah, geez.
Once you have it in 2 equal-ish pieces, turn to your neighbor and exchange half. So now each group has 2 colors. Okay, try that again. Yes. So, and hopefully your 2 colors are different from each other. So now does everybody 2 group or 2 different Play-Doh? Okay.
Yes, ma'am.
Now what we're going to do with these different Play-Dohs is we're going to all demonstrate principle of original horizontality. So read your definition, work together. Okay, so work together and show me principle of original horizontality.
Okay, let's see. Well, we did it already.
So we're going to come around and check on you.
We'll get there.
I love my very much. Carter, Zach, how's it going? Zach, what's up? Yeah, I need to see principle of original horizontality.
Yep.
Okay?
Good. So you said I was good, so what was that one?
The only thing I'm gonna ask is it does say that they are layers.
But we don't have a knife.
Oh, if anybody needs a knife, you can come on up and grab one. I'm sorry. So I would like you to avoid letting them mix as much as possible. So please do not push them together. They can touch. And if a little bit gets mixed, that's fine, but please let's not just grab them and make one giant blob. So a couple things I want to clear up. So do I see everybody's? I don't actually know if I do yet. So one thing I want to talk about, so if you are done, just pay attention up here. It says that rock layers are originally deposited in horizontal layers and were tilted after deposition. So I actually want to go back a step. Do you guys remember how sedimentary rocks form? Deposition, sediment get deposited. So here I am depositing a bunch of sediments. This was not part of what I asked you to do, but I am asking you to pay attention now. So here's a bunch of sediments that are getting dropped off by agents of erosion on this blue sheet of paper. After they get dropped off, what happens to the sediments? And maybe you can see still up on the rock cycle chart. They get deposited, buried, compacted, and cemented together. So really what that means is they get formed into a nice flat layer. So that is how one sedimentary rock layer forms. One thing I want to clear up, guys, is I'm not actually talking about a rock that's about the size of my hand. Hey, up here, guys. So I'm not actually talking about a rock the size of my hand. I'm talking about a rock the size of Pioneer. Okay? I'm talking about huge bedrock layers, not just a rock that I can hold in my hand that has layers. I'm talking about kilometers long, kilometers deep rocks. So here's one layer. Now, once this rock is there, compacted and cemented together, we have a new sedimentary rock. What's going to happen on top of that rock layer? Another thing. So a couple, maybe million years later, new sediments are going to get deposited, buried, compacted together. And sorry, just to make this work a little better. So there was our first blue layer that was already there. Now a new layer of sedimentary rock forms. Slightly different rock. This one might be made of bigger sediments or smaller sediments, or maybe a mixture of sediments. It's hard to say, but a new layer. After that new layer is there, what's going to happen? After this new layer is there, another one, and another one eventually. So see how they're not, I'm going to tilt this so you see the side view. But see how the layers are nice, neat, and horizontal across the paper? That is principle of original horizontality. The thing is, so now these beautiful layers are there. They're nice and horizontal. Anything that happens to them afterwards, for example, maybe another plate comes in. My hand's going to be a plate. And they could totally tilt each other and make a mountain. When did that tilting happen? After the rocks were deposited. So how do you know it happened after they were deposited? So how do you know that a rock gets tilted? How do you know a rock gets tilted after it was deposited? How do you know? Guys, stop with the Play-Doh. We're actually learning right now. But that wasn't my question. Answer my question. How do you know a rock was tilted after it was deposited? kind of, so I know what you're saying, it won't be a horizontal layer, but let's think about this. Guys, stop with the Play-Doh. How do we know a rock was tilted after it was deposited? Think. You're overthinking it. You want to try, Jeff? If it doesn't exist, can you tilt it? Okay, no. If a rock's not there, you can't tilt it. So you can only tilt a rock after it's made. So that's what this principle of original horizontality is saying. They're originally always made. You can count on that. That is a fact. Sedimentary rocks are always made in horizontal layers. So if I asked you to put them in order, what happened first? The rocks had to be there before they could be tilted. So how should we go about drawing a picture for principle of original horizontality on page 15? So we already have a description. What picture should we draw for that? Layers. So I'll show you exactly what I was hoping you would draw. So here in this section, I was just hoping you'd have some nice horizontal layers. I am going to color in one layer just so I can see that that is a different rock than the other one. Now, can I add, guys, these are your notes for this. Nowhere else are we going to talk about the principle of original horizontality. Here is where your notes are for that. So you guys should all have your Play-Doh set up like mine was. If you've destroyed it, fix it. You need to have a set of Play-Doh that looks like this.
Give me the 9 part of it.
It doesn't have to be perfectly squares like mine are, but you do need the general gist of
There are
it.
more knives.
There are more knives. No, I'm not throwing a knife at you. Once you have these perfectly horizontal squares, I want you to read the principle of superposition and tell me what we need to do or change to demonstrate principle of superposition. Okay, guys, we're trying to do superposition now.
Oh, we're doing the other.
No, principle of superposition is the second one down. How do you know which one's older? On the bottom. So whichever one's on the bottom is the oldest, but my question is, why or how? Exactly, it has to start at the bottom, just like when you're making a layered cake. You can't start with the top layer and build underneath it. You have to start with the bottom layer, then another layer gets put on top of that, and then another layer on top of that, and another layer on top of that. I like to relate this to a clothes hamper, but do you guys actually know what I mean when I say that? A laundry basket. Now, my next question, and this one I'm afraid of the answer. Do any of you know how to use a laundry basket? You put your laundry in it. Now, I'm also questioning, should I call your parents and ask them if you actually know how to use a laundry basket?
I do.
No.
You can go ahead and call mine. I do want
Good. But
to.
okay, so my kids also know how to use one, they just choose not to. And yes, they do their own laundry too. I refuse to do their laundry. But guys, how is this related to a laundry basket? Carter, since you know how to use a laundry basket, how is the principle of superposition? How can we relate that to a laundry basket? You want to try, Kaden? Wait, do you know how to use a laundry basket? Do you actually use one?
Yeah.
Nice, okay. Oh, it's in your closet, okay. So Cadence, what were you gonna say before I was joking around with you?
Oh,
The oldest dirty clothes, so let's say you do your laundry on Sunday night. Where do your clothes on Monday go? In the bottom, and then Tuesdays? On top of those, and Wednesdays? On top of those, and Thursdays? And then Friday. So where's the oldest laundry? Right, Monday is the oldest laundry, so that's the one at the bottom. Friday's laundry, which is the youngest laundry, is right at the top. So if you had to, like, if you forgot your wallet in Tuesday's laundry, you gotta dig through down towards the bottom, yep. So what are we gonna, so do you have this already made? Your layered rocks? Your layers of rocks?
Yeah.
What do we do to this pile of rocks to demonstrate principle of superposition?
Smush it.
No. What do you want to add? No, we're not on the flip one. We don't want to change anything. All I want you to do is add a label that says oldest, youngest. So it will lit on your drawing.
We have to redraw it.
Literally.
What do we? Well, not.
So I'm gonna draw the exact same picture I drew for the top one.
What about the middle child?
Does middle child matter, or is it just like the TikToks I see, they don't matter at all?
I don't want to offend anyone, but I'm only labeling the oldest and the youngest.
Well, the middle child does not matter.
Yes, that's a great idea.
That's me.
Oh, is it you, Carter? It's you guys too.
What a loser.
You, the
What a
other one?
loser. I'm the youngest one. I'm the oldest in the room. You guys are Smith and Mr. D.
Oh my God. All right. So you guys see what I did there? I took the exact same picture and just added a label. Oldest on the bottom, youngest on the top.
The middle does not matter.
And Carter, just for you.
Yeah.
Okay. Now we're moving on to faulted strata. What was faulted strata? Broken what? Broken layers. So I'm not just talking about broken pieces. We're not talking about sediment. We're talking about whole layers get broken. What are we gonna do to our model? Split it in half. Which way though?
Down the middle.
This middle?
No, like
No.
flip it up.
The other way. I am going to, you can cut this with your knife if you're careful. Please try not to mix them as much as possible, and I gave away my knife, so I'm ripping them and putting them back together. So faulted strata are the same rock layers we've had the whole time. Guys, what in the world is strong enough to break entire layers? Earthquakes, plate tectonics. This is not running water erosion. I was aware. I did feel it. Did you guys? I was absent that day. I think it was in lab though. So I think I did get a little overly excited and then a little disappointed that the one day there was something cool earth sciencey, I wasn't going to be in school.
I wish it would have broke my house.
But did any of you guys feel it? Oh, yeah. So it feels like it sounds like not too many people felt it out here. Yeah. So I thought a tree fell on our house or that something exploded. So I went and checked out everything. And it was an earthquake. All right, so faulted strata. Earthquakes are the only thing strong enough to break these layers. Because again, remember, we're talking about layers of rock the size of the entire Pioneer School District. We're not talking about one's just the size of the school. I mean, the whole school district. So an earthquake happens and it breaks these rocks. What I want you to notice is, can you still tell in this way which one's the oldest? The one on the bottom. The youngest on top, yes, the middle child still in the middle. But what happens if these were broken and then they pushed together and went like that? Now our layers are all messed up and it's hard to see which one's oldest and which one's youngest. So faulted strata can make it hard to figure out law of superposition with the oldest being on the bottom and the youngest on top. So what I would like to do for this drawing is almost the same drawing. I'm going to have the same 3 layers, but I'm going to have a giant break in between them. That's one way you can demonstrate faulted strata. But what if they only moved up a little like this? Now can I tell which one's the oldest and which one's the youngest?
Yeah,
How would you do it, Carter?
the blue on the very top is the oldest. Oh, no, that's blue.
It's blue.
Oh.
It does show up a little purpley up there, but it's
You're
blue.
wrong.
That's the,
Oh,
what's this one? You might have said it, but I was distracted. This one's the,
oldest. The one on the left is the middle.
these ones right here where my fingers are at. Oldest or youngest?
Oh, no, they're youngest.
They're the youngest because they're on top. Then you go down another layer, they get older. Even though they're not lined up, guys, I'm teaching. We can't play with Play-Doh if you can't pay attention when I'm teaching too. So the top layer, even though they're not both perfectly lined up anymore, that's still the youngest. Go down another layer, they're getting a little older to the oldest, even though they're not lined up perfectly. The next one I think is maybe the most difficult. What I would like you to draw or to figure out is an intrusion. What do you need for there to be an intrusion?
Probably.
Read the description. What do you need?
Hot magma.
You need hot magma. I'm passing out some hot magma. Careful, it's hot. Boom. Here's some hot lava. Please. Careful, hot. Carter?
No. Thanks,
I gotta get you guys some hot. Carter?
Yeah. Yeah, I was.
So hot.
What's an intrusion? Did you guys make one yet?
No.
Hey, make it. Don't squish them, man. They can touch you.
Making in the crack, which means right here. Hey, buddy, I need some.
Is that an intrusion?
Well, no, there's magma between my cracks. Magma between my cracks. There's something wrong with
Something wrong with that. Reread your description.
Yeah, probably everything.
We wrote, okay, well, we didn't. All right. Guys, with the word intrusion, where is it? Inside. So it looks like we didn't write that yesterday. Write that somewhere. I'm gonna write it right here.
Like, how we should do it.
So so what is just missing from yours then, Carter and Zach? So how about this? Here's mine. Where does lava come from? So volcanoes, but it comes from inside the earth, right? So this is the top layer, the youngest. An intrusion is when hot magma squeezes up through a crack, but does not make it to the surface. And you're going to end up with something that looks like this. So see how we still have our rock layers. Let's see if I put this, there we go, it looks better on the black table. So see what I got going on here? I still have my pink layer on the bottom. Then my blue layer, then my pink layer, and then the lava squeezes through those layers, but does not make it to the surface. It's still covered by that rock layer on the top. It did not make it to the top. Do you have a lid on it? That was what was missing from yours originally, was a lid. And by a lid, I mean a top layer. It doesn't make it to the surface. Perfect. Don't draw anything yet, because we got to talk about this one. So there's one more concept that we wrote about an intrusion. What does it say, guys? Go back, guys, with the Play-Doh. First of all, you should still have your original Play-Doh. Nothing else, nothing more. What does it say about an intrusion that we did not cover yet?
Contact metamorphism.
Contact metamorphism. Let's review. What is contact metamorphism? Okay, so remember, we talked about this a couple chapters ago. I was hot lava. And I would assume I touched Carter's shoulder. What happened to Carter's shoulder when I, hot lava, touched his shoulder? I burned his shoulder. Did I melt his shoulder? No, I just burned it like a marshmallow. Yes. How were his toes? Why were his toes fine? The hot lava didn't touch his toes. Hot lava only changes or burns what it touches. So in this example here, that white lava is going to burn the rocks around it, and we need to show that. I want you guys to draw this one the exact way I draw mine. So sorry, you're going to lose your creativity here. So I'm going to still draw some rock layers. This time I'm going to have 4 layers. And my lava is going to come up through. And it's going to go through and burn and make it through. But notice how my lava got stuck. Did not make it to the surface. But again, what's missing from my picture is that contact metamorphism. So to show the contact metamorphism, the Regents will always show it with these little marks. So they almost look like little whiskers that I'm putting on my contact or on my intrusion. So it kind of looks like a worm with little leggies or little hairs or something. Caterpillar, yeah. Looks like a fuzzy caterpillar. So notice, guys, how there is that again, those, maybe we should label those. The little hair things are contact metamorphism. Those little whiskers or the little hairs are showing where the rocks around the lava burns or changes the rocks around it. Notice how there's contact metamorphism all around the intrusion. So I got a question then. If I labeled these A, B, C, and D. So guys, I'm teaching, even though I know we're playing with Play-Doh. So I just labeled these A, B, C, and D. Which layer is the youngest? But what about the intrusion? Is the intrusion younger or older than the top layer
Younger,
B?
because D is still on top.
Okay, that's part of it, but how else do I know it's younger?
Because it's not yours, you want to be there.
Okay, say it again louder, and everybody listen to Keith. Okay, can't go through. Another way I like to talk about it is D burned?
No, okay. Yeah.
How do I know D is burned?
The hairs.
The hairs, the whiskers, so there is contact metamorphism on D. Can I burn something that's not there?
No.
No. Can I burn a rock if it's not there? No, I cannot burn a rock unless it's there. So D got burned. So D had to be there to get burned. So A was there because A got burned. B was there because B got burned. C was there because C got burned. D was also there because D got burned. What can I do to my model here to make it an extrusion now? Make it go through D. Now my lava has made it to the surface. It's now an extrusion. Why is it an extrusion? Because it's on the surface now. So we're going to draw this exact same thing that we drew for an intrusion, except for the lava is going to make it up over D. So I'm going to do the same model, layer A, layer B, layer C, and D. But now my lava is going to come up through and go on top. So it's the same exact thing, except it made it to the surface. What about the contact metamorphism now? Where? Does A get contact metamorphism? Why does A get contact metamorphism? Because it's touching it. Does B get contact metamorphism? What about C? Carter, what about C?
Yeah.
Why? Because it's touching it. What about D over here? Yeah, it's there. What about here? Yeah, because the lava is touching D. Not the top. Why not the top, Sarah? There's nothing there. We can't burn it. But I got a question. What happens in another 1,000,000 years after this has sat there and cooled down? More layers are going to form on top. Now I have this new layer on top. Guys, we're not done. Here's this new layer on top that formed 1,000,000 years later. The lava is cooled and hardened. Does this now change to an intrusion? Why not? Because it's already cooled and hardened. So if I was to draw this new layer E on top, would E get contact metamorphism? Why not? Because it's already cooled and hardened. So if you saw these two pictures, D and E, what about what about the intrusion makes it an intrusion? And what about this picture makes it an extrusion? If you saw these two pictures, and I said, why is this one an intrusion and that one an extrusion, Damien? You can tell by the contact metamorphism. I say that the top of the extrusion is bald. See how it has no whiskers?
Yeah.
If it's bald, it's an extrusion. It means that E was not there when that lava was still hot. You have about 5 minutes left. You have two options. Your homework, everybody turn page 15 over. Your homework is page 16. There are 4 questions here. If you can see on the board, I asked you to pick 2 of them. So this is your homework. Pick 2. 1, 2, 3, 4. There is writing involved. You can either work on the next 5 minutes on your homework, or you can play with Play-Doh. Either way, make sure your second color gets back to the right owner. And make sure your lava gets put back in the lava container, the black lava or the white lava container. Yep. So you guys, so Cadence, you were talking about making a pizza. Question 4, how is geological history like a pizza?